Hi everyone. Today we're going to be looking at using Gaussian elimination. We've learnt that before, but we're going to have a new method of setting it out, which is based on matrices. It's called an augmented matrix. So here's a lovely system of equations, which I've got here for you. Now, before we start solving these in the Gaussian elimination method, we're going to rewrite this and save ourselves an awful lot of space. So notice that I've got the X, the Y, the Z pronumerals all lined up neatly in order, and there are constants over here on the right-hand side. That's fine. So all I really need to work with is the coefficients. Writing the first equation, I'll put a 2. Instead of a Y, I'll have positive 1, a positive 1, and then the 6 over there, the constant. Using row number 2, it would be just the coefficients, so 1, positive 1, positive 1, positive 1, and a 4. And then the third equation, our coefficients are 2, 2, 1, and 5. So I'll write this as a matrix. And in order to distinguish the fact that the 3 by 3 part on the left is the coefficients of the pronumerals, and the column vector 4, 6, 4, 5 on the right are the constants, I'll put that little dividing line down there between the third column and the fourth column, so that we've got what we call an augmented matrix. Now, the Gaussian elimination technique that was the topic of the last video can be applied to this augmented matrix. And whereas we were adding and subtracting multiples of entire equations, we would now add and subtract multiples of one row or another. Now, here's the summary over there of the elementary row operations that are allowed to be performed. We can interchange two rows. We can multiply a row by a non-zero number. Clearly, if we multiply by 0, we get nothing plus nothing plus nothing equals nothing, which is lost all meaning from the original equation. So multiplying by 0 is a no-no. And finally, we can, this is like we were doing last time, add multiples of one row to another row, and that's the equivalent we did last time of adding multiples of one equation to another whole equation. So the plan for this is we want to end up with an equation that looks, or sorry, an augmented matrix that looks like this. And now this would be great. And there'd be some number here, some number here, some number here. If we could get to that, we would know exactly what our X, Y, and Z values were, because our first row literally would read 1 times X plus nothing else equals that number. In other words, X is that number. And this would read Y equals that number and Z equals that number. Now, we may or may not get all the way to that stage. It is possible that we could get to a point here where we've got other numbers, non-zero numbers, in those places. And that's still quite a good place to be at. If we could get to this point, we could read the value of Z directly from the third row. Then we could back substitute that value to there and calculate the value of Y. And then we could back substitute both our Y and Z and calculate the value of X. So it's not too bad a place to be at. That would be our first goal. And if possible, we would keep going and get to the identity matrix here as the 3 by 3. So let's see how we do this using our elementary row operations. Well, my goal obviously is to get these leading diagonals all as ones with zeros below them. This is called row echelon form. That's the name of this. Have to remember how to spell that. That's it. So if we can get to row echelon form, we're doing well. And we're only allowed to use those elementary processes. Look, I think the first thing I want to do is switch row number 2 with row number 1. And that way, I'm going to immediately get this value of 1 sitting in the place where I need it to be. So let's go ahead and do that. So I'm going to put row number 2 at the top. And then I'm just going to move row number 1 to there, and row number 3, well, it's just not going to do anything. It's just going to sit there. Now, how will I make a little note to explain my reasoning? What I'll say is that the new version of row number 1 is the old row number 2, and the new version of row number 2 is the old version of row number 1. Literally, we've switched rows. Now I've got a 1 there. That's brilliant. In order to get to row echelon form, there's a strategy we should follow. So the first strategy, or the first step, is to get the leading 1 in the first row. Then the next part of the strategy is to get zeros below it. Don't care about anything else at this stage. I just want that first column to be looking good. And remember, I can only do those things there. So let's see what we're going to do. Well, I'm not going to change row number 1. Row number 1 has already got that leading 1. So row number 1 is fine. But I want to get a 0. In fact, I'll even write it in. I want to get a 0 there. Now, how could I produce a 0? So new version of row number 2. Looking at the previous ones, that would, if I wanted to get a 0, I'd have to have that take away 2 times the one above it. So it's literally old row number 2 minus 2 times old row number 1. And we do that across each of them. So we've already gone, this subtract 2 of those is nothing. Now I'd have to have this one subtract 2 of those. So that's 1 take 2, that's negative 1. I don't care that it's negative at this stage, I'm just getting that 0 at the front. Now I need to have this one take away 2 of those. Once again, that's 1 take away 2, that's negative 1. And then I'd have to have 6 take away 2 4s. So 6 take away 8 is negative 2. So I'm happy that I have a 0 there at the beginning of row 2. Now I want to produce a 0 at the beginning of row number 3. So I have to go back and look at what we're doing there. Again, I could go old row number 3, subtract 2 of row number 1. So let's write down that. New version of row 3 will be the old row 3, subtract 2 of row number 1. So let's go a bit faster this time. That's 2 subtract 2 ones, so 2 subtract 2 is nothing. Then I'll have 1 subtract double that. 1 subtract 2 is negative 1. Then I'll have 5 subtract 8, that's negative 3. Well, we're pretty close to row echelon form, aren't we? We're pretty close. In fact, I've just by chance ended up with a 0 here as well. That was handy. Now, I could multiply, remember, I can multiply rows by non-zero numbers. I could multiply row 2 by negative 1, and I could multiply row 3 by negative 1. And then we'd be looking pretty good. So row number 1 is 1, 1, 1, then the 4. So new version of row number 2, this one, is negative 1 times old version of row number 2. So 0, 1, 1, 2. And new version of row 3 is negative 1 times the previous row 3. So 0, 0, 1, 3. We have got row echelon form. At this stage, if I wanted to, I could go off and solve these. I could go, well, what does that tell me? By looking at row number 3, I could state that z equals 3 directly because 0x plus 0y plus 1z equals 3. By looking at row number 2, I could state that y plus z, now I know z is 3, equals 2. That follows quickly that y equals negative 1. And by going back to row number 1, I could state that x plus y plus z, but I already know that y is negative 1 and that z is 3. and that all equaled 4. So that, I hope, tells me that x equals 2. Is that right? That would be 2. 4 take 2 is 2. Yes. So I've got my solutions. My values for x, y, and z, I write that as a vector, x was 2, y was -1, and z is 3. So that's how we go about using Gaussian elimination on an augmented matrix. The setting out is so much more compact than when we were writing all the equations out, but it is the same process. Now, the strategy, remember, is first get that leading one in the first row, then get the zeros below that. The second thing to aim for is a leading one in the second row and get a 0 below that. And then finally, oh, should be a different color there, get a leading one. Oh, that's awful. I've made it horrible there. Get rid of, oh, now I'm ruining everything. Finally, we will aim to get that leading one in the, oh dear, in the third row. Oh, I'm having trouble today. So that's row echelon form. Now, just to show you, this can be done with technology as well. So I could enter this matrix. Now there's a few different ways to do this. I could go options and then I could go, sorry, go back from there. I could go maths and then I could go matrices and then I could ask for a 3 by 4 matrix. So there it is. I'll enter the original augmented matrix. So 2, 1, 1, 6, just using the right arrow to move, then 1, 1, 1, 4, and then 2, 2, 1, 5. There's my matrix. Now, just go back to that, go back up to there and go to the, see the cursors there at the front? Now I'm going to press the Options key and the Matrix menu. And if I go across here to the side a bit, I can ask for row echelon form. Row echelon form of that matrix is what? Ooh, did we have that? Or we probably had something equivalent to that, didn't we? Now, if we look at this, we get that z equals 3. We get that y equals -1. And if we back substituted those into here and solved, I'm sure we'd get the same. Now, we can also ask, this is the good bit, I'll just take that out. We can also ask here for reduced row echelon form. See the extra R? A reduced row echelon form gives us what we were talking about there at the start with that identity matrix for that 3 by 3. And these literally are the answers now because one lot of x plus nothing else is 2. One lot of y is -1 and 1 times z is 3. And that does match the solutions that we had. So you can do this process with an augmented matrix on pencil and paper using elementary row operations, or you can do the process on the calculator and you can either ask for row echelon form, which is what we got to, or reduced row echelon form. So lots of practice needed to master this. And that's it for now. See you next time.